The Hyperledger Foundation's 2025 annual report notes that Fabric remains the most deployed enterprise blockchain, accounting for roughly 46% of permission deployments. So when IBM Research released FabricX and put a number on it, 200,000 transactions per second, anyone building regulated digital asset infrastructure had to take it seriously. But a white paper claim and an actual performance are two different things. Today, I'm joined by Neethu, the engineer at Espeo Software, who took FabricX apart and built two working prototypes on it, also tested its promises against a real estate tokenization scenario. By the end of this conversation, you will know what FabricX actually is, where it lives up to the paper and where it doesn't, and whether it's something that you can today use in a regulated project or not. A quick disclaimer here. We assume that you have at least a basic understanding of Hyperledger Fabric. If you don't, watch our previous video on how it works and then come back. Hello Neethu, it's great to have you with us.
I'm really happy to have the chance to talk about this project because it was a really interesting experience for me. I have been working with Hyperledger Fabric for a while now. So when FabricX was announced, I was really curious to see what was actually different about it. And after building a couple of prototypes and testing it hands-on, I found some really interesting ideas along with few challenges as well. So I am looking forward to sharing that experience today.
Neethu, let's start by setting ground for everyone. FabricX carries the Hyperledger Fabric name, but you keep stressing that it's not an upgrade. Tell us in a simple way what FabricX is and why does that re-architecture, not an upgrade distinction actually matter?
Probably the most important thing to understand about FabricX. Despite the name, it's not the next version of Hyperledger Fabric. IBM Research redesigned it from the scratch with a completely different architecture. Now, if you look at classic Fabric, it is a general purpose enterprise blockchain. You can build supply chain systems, identity solutions, asset tracking, and many other blockchain solutions or business application on it. FabricX, on the other hand, it is much more focused. It was designed specifically for digital assets and financial use cases like tokenization, CBDCs, and interbank settlement. Because of that, it introduces several new features like UTXO-based token model, built-in privacy with zero-knowledge proof, a new consensus mechanism called ARMA-BFT, and a completely different programming model. So this is why that distinction really matters. Choosing FabricX is not like upgrading one version of Fabric to another. You are actually choosing a different platform with a different strength and different trade-off. So if you are already familiar with Hyperledger Fabric, that's something that's really important to know. You can't simply reuse your existing Chaincode or development approach. You will need to learn a new programming model, new tooling, and a different way of building applications.
One of the biggest challenges, let's be honest, I needed time to wrap my hand around it. In classic Fabric, you write your business logic in a standard way, in Chaincode. FabricX replaces that with Fabric Smart Client Views, something completely different. Could you explain the change?
This was probably the biggest mindset shift for me as well. In classic Fabric and actually in many other blockchain platform as well, most of your business logic lives inside the chain code. For example, when a client sends a transaction, every peer node execute the same chain code independently. And if everyone get the same result, then the transaction is returned to the ledger. But FabricX take a different approach. Instead of putting all the logic inside the chain code, it moves a lot of that logic into communication between the participants before anything is written to the blockchain. And that's where the Fabric Smart Client or FSC comes in. FSC lets different participants communicate, exchange information, collect approvals, and agree on what should happen before the final transaction is submitted to the ledger. Okay, let me give you a simple example. Let's say bank A want to transfer an asset to bank B. In classic Fabric, the transaction goes directly to the chain code and the chain code decides whether it's valid or not. In FabricX, bank A and bank B first communicate, then verify the transaction and collect if any required approvals are there. And only after everyone is agreed the transaction, then only it's submitted to the ledger. So for me, that's really the biggest difference. So classic Fabric is transaction first, while FabricX is collaboration first. The participants coordinate first, and the blockchain simply record the final agreed result.
Exactly. And this idea of collaboration first, a genuine advantage or just different mental model to learn? Could you tell us about the benefits and challenges of this new approach?
I think it's actually both. The biggest advantage is that for financial application, it feels much more natural because that's already how many the real world process work. Banks, payment providers, financial institutions usually exchange the information and confirm everything before actually they settle a transaction. FabricX models that process directly. So things like approvals, complaints check, and multi-party workflow become much easier to build. But at the same time, there is a trade-off. It's completely different way of building applications. If you're coming from a classic Fabric, you can't simply take your existing chain code and run it on the FabricX. You need to learn FSC and understand how participant to participant communication work and start thinking about your application as a protocol rather than just a smart contract. So yes, there is a definitely a learning curve, but for digital asset and financial application, I think this programming model make lot of sense.
Okay, yeah, and now let's get back to this headline number. So, classic Hyperledger Fabric handles around 3,000 transactions per second. FabricX claims 200,000, and that states that it comes from a new consensus mechanism. So, could you tell us more about the consensus, please?
The main reason for the performance improvement is the new ordering services called ARMA-BFT. In classic Fabric, the ordering services receive transaction, orders them, and create blocks and distribute those blocks to the peers of the network. So here, the ordering services do all of these jobs alone. As workload grows, that ordering services can become a bottleneck. But FabricX take a different approach. It split that ordering service process into several specialized components like router, assembler, batcher, committer, etc. So first, the router receive incoming transaction and send them to the right batcher. Then the batcher group those transactions together into batches. Now here is the key differences. Instead of running consensus on all the transaction data, ARMA-BFT only reaches consensus on the small fingerprint of the each batch. Once that done, the assembler takes the agreed batch information and build the final ordered blocks. And it then delivers those ordered block to the peers. And the peers will validate, and after validation, they will return to the ledger. So by separating consensus from the block construction, FabricX reduces the amount of data that needs to be processed during the consensus because the system exchanges the much less data during the consensus and the work is shared across multiple components. That's why the ordering layer can scale much more efficiently, and that's where the 200,000 TPS claim comes from.
Okay, thank you for this clarification. So let's circle back to the numbers. What's the transaction speed that you experience while working on the project?
Because I was not actually trying to benchmark the platform or validate the 200,000 TPS claim. My goal was really my goal was to build the working prototypes and understand how the platform behaves. So what I noticed that for the EVM prototype, the transaction confirmation times were actually much better than what the documentation suggested. The documentation mentioned around 2.2 seconds for the transaction confirmation, but during our testing we consistently saw the transaction confirmation is roughly around 580 millisecond on a local setup. Now of course that's very different from measuring a maximum throughput. Also, a local development environment is not suitable for validating a 200,000 TPS claim. So my takeaway was this: the platform felt very responsive during the development, but large scale performance claim would still need a independent benchmarking in a production like environment.
And you didn't just build one prototype, you built two. So you put tokenization and transfer ideas into working code, and there were two tracks that were explored. So can you describe both of them?
Actually, one of the things I wanted to explore during this project, FabricX support two different ways of building the tokenized application. So I wanted to explore and compare both. The first is the EVM path. This work very much like Ethereum. You write Solidity smart contract and use familiar token standards like ERC20, ERC720, or ERC1404, and interact with them using the existing Ethereum tools. So if you're coming from the Ethereum background, this feels very familiar. The second is the native token SDK. Instead of writing smart contract, it provides built-in operation for issuing, transferring, redeeming, and querying tokens. It also works together with Fabric Smart Client, so participant can coordinate before the transaction is committed, while privacy is built into protocol using the zero knowledge proof. So, although both approaches let you build the tokenized asset, but they are designed for different needs.
Okay, and what did you learn about when and where those tracks apply?
They are not really competing solutions. They are solving different problems. If you already have experience with Ethereum and you need ERC standards, or you want to reuse your existing Solidity tools, then EVM path is the natural choice. And the learning curve is much lower because the development model is already familiar. On the other hand, if privacy is the main requirement, then native token SDK is the stronger option. And it was designed specifically for the digital asset with the privacy and complaints built into the protocol level rather than added through the smart contract. So in the end, the choice really depends on the project priorities. If compatibility with Ethereum ecosystem is most important thing, then I would choose EVM path. But if protecting sensitive financial data is the priority, then I would go with the native token SDK.
And that it depends, it's the part that gets difficult. In a demo, you can check and try out both paths and decide on pure technological results. In a regulated build, the path gets decided by things that sometimes you can't even see yet. Working out which of those actually determines the choice before you've built on the wrong one is the work that our digital assets team at Espeo Software does for banks and fintechs. So if that's the call in front of you, reach out via our form and we will gladly help you out. And back to you, Neethu. You mentioned sensitive financial data, so let's talk about keeping secrets and data security in FabricX. I know that investor A simply can't see the investor's B balance. The balances are masked at the protocol level using zero knowledge proofs. And the ZKP is something that a lot of people in blockchain, financial, medical industry cheer on. So walk us through what privacy built in by default really means for the FabricX and how does it affect the performance?
I think the easiest way to understand it is to compare it with a typical public or a private blockchain. On most blockchain, every participant can see every transaction and every balance. Even if the identities are hidden behind the wallet address, the transaction history is still visible. So with the FabricX native token SDK, it's worked differently. The protocol is designed so that only the parties involved in a transaction can see its details. Other participants cannot see your balance or the transaction history. And I actually wanted to verify that myself, so I tested. When a investor A tried to query investor B's balance, the request failed. The same happened when investor B tried to access the investor A's balance. So that means each participant can only see their own asset. That possible because of the zero knowledge proof. ZKP allowed the network to verify that the transaction is valid without revealing the confidential information like balance or the ownership details. So as for the performance, I did not see any significant impact during the scenario I tested. The token operations completed successfully while still maintaining the privacy. So, of course, measuring the actual performance overhead of the ZKP would require much larger scale benchmarking. But based on my experience with the prototype, I am optimistic about how this implementation can scale.
And it's worth mentioning that while for the FabricX SDK, ZKP privacy is native, it changes when we enter the EVM path. What changes in that area by going the EVM route?
The EVM path follows the Ethereum model. So transactions and balances are transparent by default. So you still get the familiar Ethereum development experience and support for ERC standards, but you don't get the protocol level privacy that the native token SDK provides. So if you are working on EVM path and if your application needs confidential balance or the private transactions, you will have to build or integrate additional privacy solution by yourself. So that's really the key differences. The native token SDK treats the privacy as a core feature of the platform, whereas the EVM path, it's something you need to add separately if your application needs it.
And this is the one I want engineers to hear. With the ERC 1404 standard, engineers can get the compliance behavior working. Mint, block transferred, whitelist, sender, removed, all those cases. But you flagged something that matters for a regulated product. There is a scenario that leaves no trace on chain. Yeah, and what's that and why is that a problem?
ERC 1404 complaints work really well for all the standard scenarios like minting, whitelisting, blocking transfers, and removing the centers. Everything worked as expected. But while testing, I found one important limitation if you're building a regulated product on EVM path. When a transfer is blocked by a complaints rule, the transaction fails and it is expected behavior. But the smart contract doesn't emit an event showing that the transfer was attempted and rejected. Now, why does that matter? For many applications, it probably doesn't matter. But for a regulated financial products like real estate, tokenization, or a digital securities, the complaints team often want an audit trail for both the successful and the rejected transfers. For example, if an investor tries to transfer a token to a wallet address and that wallet address has not passed the KYC process, it's useful to know that the attempt happened and why it was rejected. By default, that information is not available from the smart contract.
Okay, is there any way to work around it?
Yes, there is. The simplest approach is to record those failed attempts at the application layer. So when a transfer fails, the application can log who initiated it and when it happened and what restriction caused it to fail. So that gives the complaints teams the audit trail they need, even though the blockchain itself doesn't store those failed attempts. So it's not really like a blocker, but it's just something you need to design for your application if it has a strict audit requirements.
So you found out that the core of FabricX works. Issuance, transfer, and redemptions, they all held up. But it's not all hearts and flowers, is it?
Overall, I had a really positive experience with this technology. The core capabilities worked very well. I was able to build both the prototypes, validate the token lifecycle, confirm the privacy model, and explore the EVM layer. So from a technical perspective, I think there is a solid foundation. But at the same time, it's still an early stage project. The community is relatively small. The documentation is still quite limited. And when you run into any issue, there are not many existing examples or discussion to help you. During this project, I actually spent quite a bit of a time reading the source code and experimenting to understand how certain features work. So now that's pretty normal when you are working with a new technology, but it's definitely something that team should be prepared for.
Okay, so who should be looking at FabricX today and who should wait? And what would have to change before you would put it into production?
FabricX is a really interesting platform for teams building digital asset, CBDC, tokenization, or privacy preserving financial applications. So if you're doing research, building POCs, or evaluating the future architecture, it's definitely worth exploring. When it comes to production system, I would be a bit more cautious at this stage. Before I would be comfortable using it in production, I would like to see larger community, more mature documentation, more production deployment, and a broader real world adoption and a stronger long term support. So the good thing is FabricX is now the part of the Linux Foundation. So it has the backing of a mature open source organization and a clear path for the future growth. So my recommendation would be experiment with it now, learn how it works, but carefully evaluate its maturity before choosing it for a production system.
Yeah, these are great points. Also, the creator state, it's not yet a graduated Hyperledger project, which means it hasn't passed the maturity reviews required for a production endorsement. So I need to say that it's a clear statement and a growth path, and that's one of the benefits of having a mature organization like Linux Foundation behind it. And getting back to your experience, how would you sum up your experience of building on infrastructure this new? What else should a team expect if they pick up this project this early?
Building on a project this new is really exciting, but it also comes with its own challenges. You can't always rely on documentation or community discussion, so you end up spending more time reading the source code, experimenting and understanding how things work internally. So during this project I found a couple of issues that were not documented. The first was the bug in the FabricX EVM gateway. Some application would ask for the latest blockchain events and get an empty response, even though the data is actually existed. So I investigated it and reported to the FabricX maintainers, and they confirmed it was a bug. And the fix not only resolved my issue, but also uncovered and fixed several related issues in the API. And that fix has now merged into the project. And I also opened a documentation issue after noticing that the reverted ERC1404 transfer don't emit the on-chain events, which can surprise the teams building the complaints and the audit system. And after discussing it with the FabricX team, I submitted the documentation update explaining explaining this behavior, and that contribution has now been merged into the official FabricX repo. So for me, that was actually one of the most rewarding part of the project, being able to contribute back to the platform while working on the POC. And for teams considering FabricX, I would say be prepared to invest time in understanding the platform, budget extra time for debugging, expect to read the source code, and have engineers who are comfortable working with evolving technology.
Neethu, a big round of applause for being a part of the community by reporting and documenting real issues. Thank you for today. So the honest verdict is that FabricX is where you go to learn tokenization native future, but not yet where you put a regulated system into production. For that, you are still deploying classic enterprise-grade mature Hyperledger Fabric and getting it to survive production and infrastructure team and a finance review on top of that is its own problem, most of which has nothing to do with the blockchain. We built exactly that end-to-end on Kubernetes across 2 cloud providers and documented it on our channel, so make sure you watch that video as well. To our viewers and listeners, thanks for joining us, and as always, remember to stay on the block to stay ahead.